Welcome back to the channel. So today in this video we are going to discuss another concept regarding set theory. This concept is called cardinal number of a set. So what do we mean by cardinal number of a set? The number of distinct elements in a given set A is called cardinal number of A. It is denoted by n of A. So cardinal number of set simply means number of elements in a given set. So suppose I have a set A whose elements are 1, 2, 3. So here we have only 3 elements in this set. So I can say that cardinal number of set A is equal to 3 because this set is having only 3 elements. So another example we are having here is a set A where we have the set of all x such that x belongs to natural numbers and x is less than 5. So the natural numbers less than 5 are 1, 2, 3 and 4. Here again we are having the cardinal number of set A is equal to 4 because this set has only 4 elements in it. Similarly, we have another example where we are having a set B which is set of all letters in the word algebra. If we represent this set in roster form, we'll be having the elements as A, L, G, E, B, R. As we know that repetition is not allowed whenever a set is represented in a roster form. So we're having only 6 elements in this case. So we can say that the cardinal number of set B is equal to 6. We have another category, disjoint sets. So what are disjoint sets? Two sets A and B are said to be disjoint if they do not have any element in common. So if we have two sets, suppose we have a set A whose elements are 1, 2, 3 and 4 and we have another set B whose elements are 1, 2 and 3. These sets have some common elements, so they are not disjoint sets. And now suppose if we have another set C whose elements are 5, 6, 7 and 8. So we can say that set A and set C, they are disjoint sets because they do not have any element in common. Similarly, we can say that set B and set C, they are again disjoint sets because they do not have any element in common. So another example we are having is a set A where we are having the set of all x such that x is a prime number, and we are having another set B, where we are having the set of all x such that x is a composite number. So here again we can clearly see that these two sets do not have any element in common. So we can say that these are disjoint sets. Power set. So what do we mean by power set? The collection of all subsets of set A is called power set of A. It is denoted by P of A. In power set of A, every element is a set. So in order to understand this concept, let us take a simple example. So here we are having a set A whose elements are P and Q. Now let's write all the subsets of this set A. So we'll be having 5, which is an empty set. We are having another set which will be having only one element, that's P. Another set which is having only one element, that's Q. And another set which is having 2 elements, both P and Q. So these all are the subsets of set A and we have considered this as a single set. So this single set will form a power set of A. Necessary to note here is that the number of elements of power set of A, which is equal to n of P of A, in this case is 4. So we can see that this 4 is nothing but 2 to the power 2. So in general, we can say that number of elements of power set of A is equal to 2 to the power m, where m represents the number of elements in set A. Universal set. A set which contains all the elements of other given sets is called a universal set. The symbol for denoting a universal set is U in caps. In order to understand what universal set is, let us take a simple example. So suppose we have a set A whose elements are 1, 2 and 3. We have another set B where the elements are 2, 3 and 4. And we have third set, that is set C, where the elements are 3, 5 and 7. So if we have a set in which we'll find the elements of all these three sets, such set will form a universal set in this case. So it is a simple concept that if we have three sets, suppose we are having set A, set B and set C, and we have a set which contains all the elements of the sets we have considered, such set will form a universal set. So here again, it's necessary to note that A is a subset of U, B is also a subset of U, C again is a subset of U, which implies that U is a superset of A, again U is also a superset of B, and in third case as well U is a superset of C. If P is a set of whole numbers and Q is a set of negative numbers, then the universal set is the set of all integers. So suppose we have two sets, a set of whole numbers and a set of negative numbers. So it is easier to conclude in this case that the set of all integers will form a universal set in this case. Okay, let us take another example where we are having a set A with elements A, B and C. We are having set B with elements D and E, and we are having set C with elements F, G, H and I. So what will be the universal set in this case? So it will be having elements A, B, C, D, E, F, G, H and I, which means that the elements of all three sets which we have considered. I hope this makes sense. Do subscribe the channel and thanks for watching.